So we're in chapter 8.4, the last part of this section 8, and it's called monitoring on the debt side. And what is that about? Well, there's the question, open question, what should be the financial link between the monitor and the firm itself? And in the chapters before, the monitor was either some kind of equity holder or some equity investor. And the question is, could it also be the monitoring role, could that also be performed by banks? And the answer is yes. For example, if the monitor is provided with demandable debt, because then if it's demandable debt or short-term debt, that would probably be the same debt that can be rolled over or not. In that case, if the bank has the decision at the interim date whether to roll over the debt or whether to prolong the debt or not. And if it does not roll over the debt, then the firm has a liquidity problem, and that means that somehow information gets public, and then also the share prices go down. And then again, the contracts of the entrepreneur, of the firm manager, can be made contingent, for example, on the share price, just as an example. Okay, let's look at the model. Let's see how it works. We are not going to discuss it in too much detail, but just to see how it's put together. So we have a large debt holder, could be a bank, that has a nominal claim of uppercase D at day 2. So the claim is worth PH times D in the absence of monitoring. That's PH, the ex ante success probability. And we assume that the debt is demandable in the sense that the debt holder can already demand some payment of lowercase d, but we assume that the d is between VHD and VLD. So that means that if the bank takes this lowercase d, that makes sense if he has negative information. It does not make sense if he has positive information. Okay. So, and the monitoring must dominate non-contingent strategy. So it means that the incentives must be high enough so that the banker does monitor. So we have here the according assumptions. That first one is that if I get a negative signal, which happens with probability sigma HL, then I can collect the lowercase d, whereas otherwise the firm would have been worth VL times d. So this is the value that I'm gaining in expected terms from the negative signal, so that must be larger than C. And if I get a positive signal, that's with probability sigma HH, then I will take the claim. I will not take the lowercase d, which I could have done otherwise. So the VH times uppercase D minus the value of the short-term claim must also be larger than C. So that means the D values must be in a region that it compensates the manager for monitoring. Again, we assume that I have already said that the manager is compensated with equity claims. So therefore, the manager has an incentive not to let the firm go bust. So if the equity holders, shareholders, if they see that the debt holder demands his claim, you know it's a negative signal and the share price goes down. Goes down to, you already know what the value will be, VL. Well, it's going to be a little bit more complicated than that. It's not going to be VL times R because the lowercase d also has to be subtracted somehow. Okay, so one would have to think exactly about what this equation would have to be. So that's already the whole story without any further discussion. Of course, one could, if one wanted to, look at the mathematics in more detail, but we see that the incentives for the banker to do the monitoring are there. The strategy of the banker is contingent on the monitoring result. Share price reacts on that, and therefore there's the link back to the management. Of course, in this case, one could also, if one wanted to, just make the contract directly dependent on the rollover decision of the monitor, for example. It would be an alternative. It's not always that there's just one possible contract that's optimal, but there can also be several contracts that lead similar results or even the same results. So here's one more extension that's about liquidity management. So that means that this subsection here is creating a link between the section on the chapter on monitoring, chapter 8, and the chapter on liquidity management. That was our chapter 5. What's the idea? The idea is that if we have this kind of demandable debt, then it sucks or drains liquidity out of the firm if the signal is bad. And this is something that the stock market monitoring does not do. Okay, there's the stock market monitoring. The amount of liquidity in the firm will be the same. If there is demandable debt, then liquidity will be reduced in the case of negative information. And that, of course, can also be a threat to the manager, because she knows if she misbehaves, then the probability of a negative signal becomes higher. And if there is a negative signal, then there will be liquidity sucked out of the firm, and then she will be unable to repair the machine, in the words of chapter 5. And then the project will has to be stopped. Okay, so the incentives that are created by demandable debt can be even higher. So let's just look at a short model, but it's going to be the same as before. We're not going to go into depth, but just look at some of the assumptions so we see how this machine is working. Okay, so we have one assumption that says here, like in 7.2.2, 7 is a chapter that we haven't discussed, so I just have to describe it right away. That we assume that the here for simplification, that there is the entrepreneur derives no utility from money. The RB is just normalized to 0, so he doesn't earn anything, but he gets a private benefit from the project, and possibly in addition the B from misbehaving. Okay, it's a little bit different model where the preferences of the managers are not monetary. He doesn't care about money, just cares about power. So you could think about Donald Trump. So he just wants to stay in office, whatever it costs. Right, but in office, he might misbehave, and therefore his desire to stay in office reduces the incentives to misbehave. Why? Because if he misbehaves, probability of the bad signal increases, and that will mean that demandable debt will be withdrawn, and that implies that the project has to be stopped, and that's the end of the firm. Okay, so we assume that we have a liquidity shock, and we even assume that in this case, just for simplicity, that the shock is even deterministic. That didn't make sense in chapter 5. Now it's not a problem. So whenever we can drop an assumption that we've done, Tirol often does it, just drops the assumption. Okay, 2 more assumptions here. Continuation is profitable only if the signal is good. So the VH times R, NPV under the good signal, is higher than the rho. The VL times R is not. And we also assume that the pledgeable income is high enough if the incentives are correct. So we do not have to subtract any B over delta P or so, because that comes from the remuneration of the entrepreneur. That's something that we don't need now. So if the incentives are correct, the project is continued only if the signal is good, sigma HH. And then the success probability is VH times R, but we have to pay the rho. We have to pay the I ex ante, and also somebody has to pay the monitoring cost C. And everything taken together has to be larger than 0. All right, here's the time structure of the model. So first the contract, of course, and there's the moral hazard problem with the private benefit B. Then there is information acquisition by the banker who holds demandable debt. If there is debt is demanded, so then there is liquidation and no income for anybody except for the lowercase d. Otherwise, the rho has to be paid, and then there is the final outcome, success or failure, and the private benefit of this curly b variable. Okay, right. Financial structure as follows: that the entrepreneur gets liquid assets of size rho, so he's allowed to hoard liquidity in order to be able to repair his project. And the monitor gets demandable debt of uppercase D at the date 2 or lowercase d at date 1 as before, very similar to before. And finally, is one last assumption, and we have to assume that the entrepreneur is motivated to work by a state contingent decision rule. What does this mean? Well, it means that if he, let's write it slightly differently. If he works hard, he gets the high signal with probability sigma HH, and with that probability, he can collect the curly B. That's the benefit of the continuation of the project. And that has to be larger than if he does not work, he gets the positive signal only with probability sigma LH, then he gets the curly B, plus he gets the non-curl, the straight B, that is benefit from shirking, okay? So we can rewrite that, putting the sigmas on the same side, and then we have some fraction between the B's and fraction between the sigmas. And then that's more or less the end of the model, of the story. We can, of course, have a couple of more calculations. But the idea is simply that because the demandable debt in comparison to equity finance, to the things that we've seen in the chapters before, the demandable debt drains the liquidity out of the project. And that's good because the project should be stopped in case of the bad signal, and it will be stopped in case of the bad signal. And in addition, it provides incentives for the entrepreneur to work hard because of equation 8.15. So putting all together, in this case, demandable debt contract is the optimal thing. We kind of have in the model a combination between chapter 8 and chapter 5. So having demandable debt, or short-term debt rather, having short-term debt as a feature of the optimal contract is not a big surprise. That's the bottom line here. Okay, that's the end of chapter 8. Hope you liked it. I have to say, well, I'm only teaching the chapters that I do like, and chapter 8 is one of them, and I think you understand why. Just because, I mean, this is an applied chapter because you see it's very close to what's going on in the real world. So if we have any questions about the role of the stock markets in the governance of the firm, we can use this chapter 8 as a starting point and then maybe have extensions or something like that. Okay? All right, see you in chapter 9.